Okay, so there's your function. And let's say I wanted to find the slope between this point and, say, this point. Well, how do I measure that? I guess I could draw in a triangle, right? Oh no, another right triangle. We're back to trig. No, not really. So if you looked at the hypotenuse of that right triangle, then we're trying to find the slope of that hypotenuse, right? Well, okay, what do we call the vertical distance between the 2 points? The rise, right? The horizontal distance? The run. So what do you guys know about the slope then? M for slope is equal to what? The rise or the run. See, you know a lot about slope. Okay. Now, this scary sounding thing, the difference quotient, is nothing more than a way to frame the slope formula in terms of, a little bit differently in terms of the function, a little bit differently than you're used to. So here's what I'm going to do. I'm going to label the first coordinate of this point right here. I'm going to label that x. And I'm going to label the run h. So that this value, the value in this of the first coordinate of the second point would be what? In terms of x and h? You'd have to, wouldn't you have to add h to x? Yeah, as far as what we know, we don't know any other values, so we'd have to add x to h to get the first coordinate rather of this point. So in terms of the function, I could express the first point as x comma f of x. Would you the output would be f of x, whatever that is, right? And then how could you express the second coordinate of that point? So the first coordinate is x plus h. How could you express the second coordinate? Yeah, f of x plus h. Good. F of x plus h, right? It's just all symbolism, right? So the input is whatever it is, and then the output is f of whatever the first coordinate is. So then if you find the rise between the 2 points, what are you going to subtract? You're going to take maybe this second coordinate and subtract off this second coordinate to get the rise, wouldn't you? That's one way to do it. So that would be f of x plus h minus f of x, wouldn't it? And then what do you do to get the run? Well, you could take x plus h minus x, couldn't you? So if you go back, maybe the first way you learned the slope formula is x2 minus x1 on the bottom, y2 minus y1 on the top. That's kind of what we're doing, right? We're taking the difference between the y's on top, the difference between the x's on the bottom. X plus h should be. But what does that simplify? What does that denominator simplify to be? Just h. So f of x plus h minus f of x all over h. So isn't this just the slope formula rewritten in a way that you're not used to? You might say, well, why do you do it that way? Why do something I'm not used to, right? I just got used to the other way. Just to frustrate you. No, that's not the reason. That's not the reason. So another name for that is the difference quotient. First of all, so the difference quotient is the slope. So when I fill in this blank, if f of x is a function, the difference quotient of f is this guy. And it is just the slope between the 2 points indicated of some generic function. If the function is measuring your position, so y is the position from a starting point with respect to x time. So it's a position function. So maybe it measures the distance from your house. You're running, you're on a jog, and it measures the distance from your house after X seconds. Then it could represent your average speed, your average rate of change. Remember, that's what slope is. It's a rate of change. And its units are created by taking the units of the rise and then dividing by the units of the run. So if the units of the run is in, say, well, hours. I don't know how long of a run you're going on, but hopefully it's not that many hours, right? And the distance is in miles, then the units of slope would be, okay, the rise units would be miles, the run units would be hours, or just hour. And so this slope formula, this difference quotient, could represent your average speed, right? Whether you're leaving in a car or you're just jogging or walking or whatever. So slope measures rate of change, and that's a very important idea in calculus. In this example, let's find the difference quotient for f of x equals x squared plus 5. So we're finding the difference quotient as a function of x. So, okay, if you look at the formula, it just says that, okay, let's call it DQ, Dairy Queen. It also stands for difference quotient. So you're gonna have to find, look at what it says, f of x plus h minus f of x. You're gonna have to combine all of these divided by h into one statement. But you can find it, one element at a time. Find f of x plus h. What would that be? So it's just function notation. Don't let it scare you. You're going to replace x, the input x, with the input indicated here. So the input now is x plus h. So replace the original input x with x plus h. Now you're going to need a set of parentheses around it. So you might want to go parentheses squared plus 5. So delete the x in the original formula, replace it with a set of parentheses. In that set of parentheses, replace the original x with x plus h. That's f of x plus h, right? Well, the rest of it, okay, f of x is just the formula, x squared plus 5, and then h on the bottom. So you can now you can form the difference quotient. The difference quotient, dq, is equal to, okay, if you think about it, it's this part. It's f of x plus h, right? So replace f of x plus h, the symbolism of f of x plus h, with what you get when you plug in x plus h into the formula for f. So you're going to replace this f of x plus h with x plus h quantity squared plus 5. And then you're going to subtract off from that. So that part is your f of x plus h. From that, you're going to subtract off f of x, the original formula. And if you're going to subtract off the entire quantity, you better put it in a set of parentheses. So in the green parentheses, you have just f of x. So you're subtracting the entire quantity, x squared plus 5. And that's the numerator. Does that make sense? Now the denominator is just h. I don't know why I used green there. The denominator is just h. And you're going to be required to simplify this. And I'll give you a hint. If the h in the denominator does not cancel when you're done, you did something wrong. Okay, let me show you what I mean. So now don't try to cancel yet, right? I mean, this would be turning to the dark side if you did that, right? You can't do that. You can't cancel across a plus or a minus. It's got to be a product to cancel, right? So what you can do then, your only option is to multiply, get rid of the parentheses, multiply things out, distribute the minus, that kind of thing. So let's do that. So if I multiply out x plus h quantity squared, what do I get? Good. X squared plus 2xh plus h squared. That's from the formula a plus b quantity squared equals a squared plus 2ab plus b squared. Okay, and then we still have the plus 5. What do you get when you distribute the minus? Minus x squared minus 5. And all of that is still over h, right? Okay, so anything without an h in it is going to cancel. So you see an x squared, expect it to go away. I scan, yeah, there it is. X squared minus x squared is 0. I expect 5 to go away. It doesn't have a factor of h in it. Gone. So you're left with 2xh plus h squared all over h. Is there a way to simplify that a little bit? Factor out an h. So what do you get if you factor out an h? 2x plus h left over inside the parentheses. And now that the operation outside the parentheses is multiplication, it's okay to go ahead and cancel those out. And so you're left with just 2x plus h.